Hello, to who this may concern. I, Mugweni, and my partner Oyama Plati would like to give you a quick rundown of our API called Papi IoT, giving you a demonstration of how it works. So let us begin. For our API, we decided to go for the smart home space in the IoT sector. In this space, we know there are many appliances, some for security like the smart locks, some that provide comfort like the smart TV, some that provide convenience like automatic pet feeders, and some that can manage energy. All of these are important in their own respect, but for our API, we chose to focus on the smart home security. With regarding the smart home security, our focus was augmenting our notion of the smart locks by adding features such as recognizing the face of a user or an unknown person who comes to your door. And hence we decided to make an API that can detect faces and send from photos and from videos, which can be used by users to augment their world. For the hardware that we used, as you can see by the picture, we had the Pi Noir V2 camera and the Raspberry Pi Zero W. Considering alternate cameras we thought of, we did have the Pi IR camera and the Zero Spy. However, these were impractical either from an expense perspective or from a features perspective. Ideally, we wanted our recognition to happen in both low light and normal light conditions. Hence, the no IR camera became the ideal candidate. For the Raspberry Pi, the Pi Zero was not our first choice of solution, but it was the device that we had at hand, and hence we had to work it all ahead. Moving on, let's take a summary of the API looks like itself. So this is a quick class diagram of how we structured our API. Here we have two classes revolving around the storage and source of the class. So we've got storage on the Pi, which is the offline class, and then we've got online class storage. For the online class storage, we use the Google Cloud API to store our videos and photos from that. And from the offline is just storing on the Raspberry Pi SD card. Our worker classes are the face recognition and the camera video. The camera video, as it says, provides features for recording and taking photos, whilst the bulk of the recognition is done by the face recognition class. In this class, it either can recognize from straight photos or just from a live video stream as it goes on. All of these can be put in together by this one class, which can access all these features, or you can access them individually if you would so choose. And so in summary, that's how we decided to structure our API, and that's how it works. And a nice advantage of our API is it is quite easy to use once the initial installation has been set up. The recognition and the face recognition is just one function call, and then it just works as it was intended to. Our downside though is we do use OpenCV and the dlib library extensively in our facial recognition. And these are known to be very difficult to set up, so it can get quite involved sometimes. However, if you get past that, it is quite nice. Another limitation we have comes from the hardware specifications. As mentioned before, the Pi Zero is not an ideal candidate for this sort of application, as the recognition is quite intensive, as you will see in the demonstration. However, it did get the job done to an extent. Possible extensions, as can be read, are adding more further querying to the online storage, as right now it primarily acts as more of a storage facility for dumping information for logging purposes and archival research. Moving on to the demonstration, we shall continue. So for our demonstration app, we chose a simple app which notifies a user whenever an unknown user has been seen, or you can add a new user and remove a new user. If a user is known, it draws a face around them and gives us the name of the user. If they are known, again, it sends an API, a message to the resident. Our storage class is just kept in behind the scenes, and hence I shall now play a video showing our app in motion. So here, as we're going right, you can see that our demo app is running on Grok, which is tunneling into the Pi just for convenience sake. We can just add a user by just selecting the picture with their name. We only really need one picture for them to recognize, and that's more than enough for the database to work. So now when you click and you submit the user, it sends the message to the Pi, and then it updates its database of known users. From this, we now access our video feed. However, here we see the hardware constraints start limiting themselves. So here the Pi struggles a bit, so I had to skip for convenience sake and show you what happens after the started loading. So our first test is under very, very dark conditions, as can be seen here. I've fully closed the blinds, and then although our camera can recognize a person, it doesn't give enough features for our facial recognition class to work. And so all we have is a black spot. So the reason for this is we have no infrared backlight camera, and the V2 camera doesn't come with one involved. Ideally, if we had the infrared camera, infrared light, sorry, this problem may have been solved as we'd have gotten more detail in the picture. But unfortunately, right now, under extremely dark conditions, our recognition does not work as we'd have hoped it would. However, if we do open it up a bit, as you can see now, I've increased the blind a bit, we see that our features come. The red tinting is just coming from the nature of the camera itself, since there's no infrared filter, but that is also giving us enough information for access. As you can see, it's showing the name of the user as we've added in the database, and the frame rate again is quite horrible, but it's enough to get the basic movement in, as the limitations at pi 0. Aside from this, now we can also remove the user, which is akin to banning them. So in this case, all we need to do is type their name in, and upon typing their name, it will search the query. If they're there, they'll just remove them from the list of known database users. And then again, now, if we see how it responds to me, who has now been a banned user, it should now mark me as an unknown person and send an email notification to the users. As you can see now I'm marked as an unknown person. The camera itself is not recognizing myself, and then it will send an email again, which can be seen. The email shall be sent shortly. It shall be seen very soon in the video. Moving on, as we can see now, the email has been received. For the email functionality for the demonstration app, we use the email API to configure it, and so it just sends quickly and then in a secure manner. With this, we have seen that our Pi is working as expected, and the behavior we have is the desired one. Moving on, that is the conclusion we have with the Pi in our demonstration. We've seen all the features that it has, but our biggest corner again is that we can't test under extreme darkness. In this case now, because of the lack of the infrared light in the backlight, we can't test it out, and hence some features are lost. But however, that is something that I would like to test out for prospects into the database. The functionality though was a nice thing, as we saw most of it was shown in the demonstration video. Thank you for taking the time. Good night, good evening, good morning, adieu.